Compare and contrast induction and recursion. Hello, everyone. Welcome to a lecture on the topic compare and contrast induction and recursion. We're going to look at foundational principles in mathematics and computer science. And so by the end of the lecture, you will have an understanding of both induction and recursion and their applications. Introduction to induction. So induction is a mathematical technique used to prove statements for all natural numbers. So induction consists of two main steps. First, we have the base case where we verify the statement for the initial value, which is usually n being equal to 0 or n being equal to 1. Second, we have the inductive step. So in the inductive step, we assume that statement is true for some arbitrary natural number k, and then we prove it for k plus 1. So if we look at an example, we have this statement that we want to prove that the sum of the first n natural numbers equals to n times n plus 1 divided by 2. For the base case, when n equals 1, S1 equals 1, which matches our formula. For the inductive step, we assume this formula or statement holds for n equals k. That means that sk equals k times k plus 1 divided by 2. We then need to prove it for n equals k plus 1. So this involves showing that sk plus 1 equals sk plus k plus 1, which simplifies to the same form as our original formula. So we are completing the proof by induction. And if we look at this code, we define some natural numbers that calculates the sum of the first n natural numbers using this formula, and we can then test this function with different values to show that the base case and the inductive step works. So for the base case, when n is 1, the function returns 1. For the inductive step, we can check that the function works for n equals 2 and n equals 3. Moving on, introduction to recursion. Recursion is a method where the solution to a problem depends on solutions to smaller instances of the same problem. So in programming, this often means a function calls itself with a smaller input. Recursion also has two key components: the base case and the recursive step. The base case is the simplest instance of the problem that can be solved directly without further recursion. And the recursive step involves solving the problem by calling the function itself with a smaller subset of the original input. There are a couple of examples, but I'll say a classical example of recursion will be the factorial function. So the factorial of a non-negative integer n, denoted as n factorial, is defined as n times the factorial of n minus 1. For instance, 0 factorial is defined as 1, and for any number greater than 0, n factorial equals n times factorial of n minus 1. And we have Python code that has a factorial function, and it receives n as a parameter. And we can see that the base case of n being 0 returns 1. And for all other values of n, the function calls itself with n minus 1 and multiplies the result by n, so effectively computing n factorial. Similarities between induction and recursion. So induction and recursion share several similarities. Conceptually, we both use a base case and a step case to solve problems. So they rely on breaking down a problem into smaller, more manageable parts. Mathematically, inductive proofs often parallel recursive definitions in their structure. So in both cases, the problem-solving approach involves reducing complexity by tackling smaller pieces one at a time. This reduction leads to efficient solutions to complex problems. Differences between induction and recursion. So in the previous slide, we looked at similarities, but induction and recursion also have distinct differences. The domain of application, it would be one major difference. Induction is primarily used in mathematical proofs to establish the truth of statements across an infinite set of natural numbers. On the other hand, recursion is mainly used in programming and algorithms to solve problems by dividing them into subproblems. So in terms of operation, induction is a proof technique that ensures a statement holds for all natural numbers, while recursion is a computational technique where a function calls itself to solve smaller instances of a problem. And also, induction is about verifying the correctness of a statement, while recursion is focused on computing a solution. Practical examples and applications. So if we take a look at practical examples and applications of both induction and recursion. For induction, we have this statement of proving that a set with n elements has 2 to the n subsets. For this statement, the base case would be a set with 0 elements has exactly one subset, the empty set. For the inductive step, we will assume a set with k element has 2 to the k subsets. Then a set with k plus 1 elements has the double the number of subsets, because each subset either includes or excludes the k plus 1th element, resulting in 2 to the k plus 1 subsets. And for recursion, let's consider the Fibonacci sequence. And Fibonacci sequence is defined as Fn equals Fn minus 1 plus Fn minus 2. So the recursive definition computes the Fibonacci numbers by breaking the problem down into smaller instances. And let's look at Python code. We can see the code includes a function to count the subsets. And we have a base case of set size 1, set size 0 returning 1. And for any other size, the function returns twice the count of subset of the set with one less element. And we have Fibonacci function that demonstrates the recursive computation of Fibonacci number, as well as the base case. If n is less than or equal to 1, it will return n, which is either 0 or 1. When to use induction and recursion? So understanding when to use induction and recursion is very important. Use induction when you need to prove mathematical theorems, or you want to ensure a property holds for all natural numbers. Induction is particularly useful in proofs that requires establishing the truth of a statement across an infinite set. On the other hand, use recursion when solving problems that naturally break into smaller subproblems. Recursion is ideal if you're implementing algorithms like tree traversals or sorting algorithms such as quicksort and merge sort and dynamic program techniques. They both are powerful, so knowing when to apply each is key to solving complex problems. Conclusion: induction and recursion are both powerful techniques used in mathematics and computer science. Induction is a proof technique that helps establish the truth of statements across all natural numbers, while recursion simplifies problem solving by breaking problems into smaller, more manageable parts. This is it for this lecture. Thank you everyone for listening.